Hello everyone, welcome to the Stealing Insight YouTube channel. So today we'll be treating a fascinating topic that scares students at times. It's called circle geometry. So please, I want you to follow me because the same method that was utilized in teaching me when I was in the secondary level is what I want to be utilizing at this point, because the teacher that taught me then did a lot of job in instilling this. So till today I can remember those theorems. So, but for this class, we'll be dealing with the first theorem, but I'll be laying the foundation for subsequent classes from this class in circle geometry. So when you talk about a circle, it's actually circle is a locus point in a particular plane, something like this. This is a circle. So it's actually a locus point in a particular place from a fixed point. So what we are saying in essence is that a circle is having a fixed point, which is the center. This center of the circle from this point is having an equidistance, meaning equal distance. So this is a circle. This is a circle. Now, this circle, the point that we have at this center is the center of the circle. After the center of the circle, the first thing I want us to note is that when we're having a line that divides this circle in these unequal parts, then this line is called a chord. A chord. A chord. This line is called a chord. When the line divides the circle, I mean this chord, when it divides the circle into two equal parts, something like this, or preferably in order not to create any confusion or to ensure that we are on the same page, since we've agreed this being the center, when this circle divide it into two equal parts like this, and we're having two equal parts, this is called diameter. When the chord divides the circle into two equal parts, it is called diameter. But this chord that is just dividing into unequal parts is just the line that divides into unequal parts is called chord. Now, another thing that I want to establish here is that the distance, half the distance of the diameter is called radius, meaning half of the diameter is called radius. Half of the diameter is called radius. Apart from that, when a chord divides a circle into two equal parts, the larger parts are always called major segments. Major segments. While the small parts are the minor segments. They are the minor segments. So those are the basic things. Now, between this point and this point is called the minor arc, while this point to this point is called the major arc. Major arc. When you're talking about circle geometry, the major arc. So for the first theorem, in circle geometry, this is the way I will advise you to put it in your head in order for you to be able to simplify it. So a circle geometry, just like this, as we have in the circle, it says a line. This is a chord. This is a chord. I've established that. This is the center of the circle. Now, the first theorem of in circle geometry is what I'm going to be sharing with you, and it says a line drawn from the center of the circle. A line drawn from the center of the circle to bisect a chord, meaning to divide the chord into two equal halves. A line drawn from the center of the circle to bisect a chord, which is not a diameter. this line is not the diameter because it's not going to be cutting across in this manner. It's at right angle to this chord, meaning is at right angle to this chord. So what we are saying in essence is that this is going to be forming something of this nature, a line. The theorem is a line drawn from the center of a circle to bisect a chord which is not a diameter, is at right angle to the chord. So that's the theorem. A line drawn from the center of a circle to bisect a chord which is not a diameter is at right angle to the chord. Is at right angle to the chord. Another will say it's perpendicular to the chord. So let's quickly solve questions that surrounds something like this so that you'll be able to appreciate it further. Now, I'm having this question that says a chord is 8 centimeter long, right? Calculate the distance of the chord from the center of the circle of radius 5 centimeter. Now, they said we should calculate the distance of the chord from the center of radius 5 centimeter. So if you're going to be interpreting this question, you're having the circle, a chord of 8 centimeter. This is the chord of 8 centimeter. You're having the center of the circle. Now we have been told that the radius of this circle is what? The radius, this is the radius of the circle, is 5 centimeter. And we are having this. And they're asking what is the, you should calculate the distance of the chord from the center, meaning we have to calculate for this. So how do you arrive at this? You can't just assume this, except you already understand that a line drawn from the center of the circle to bisect a chord which is not a diameter is at right angle to the chord. At right angle to the chord. So this is going to be dividing because it bisects. So it's going to make this to be 4 and this will be 4. So what we are saying in essence is that you can easily bring out the triangle now. This is 5 centimeter, which is the radius. Then this is 4 centimeter. Then this is what you're looking for. So at this point, you're going to be using Pythagorean theorem that says the square of the hypotenuse equals opposite square plus the adjacent square, right? The hypotenuse here is 5 square equals 4 square plus x square. This 25, 16 plus x square. By the time you collect like terms, you have x square equals 25 minus 16, x square equals 9, x equals 3. So the value of the distance between the chord and the center of the circle is 3 centimeter. I hope you understand this question. It's very simple, straightforward, and easy. So in order for us to save our time and to be able to understand how this works, I would love to drop this question for you to be able to interpret and solve. as the question is a very simple and straightforward one. It says calculate the length of a chord which is 6 centimeters from the center of a circle of radius 10 centimeters. So this question is very simple. You have to calculate the length of the chord. Let me just interpret it for simplicity's sake. So this is the chord. You should calculate the length of a chord, meaning this chord, which is 6 centimeters from the distance. In this way, you have been given this distance to be 6 centimeters and the radius to be 10 centimeters. 10 centimeters. So the question is calculate this. Thank you and bye-bye from the Distilling Insight. Ensure to share your answer with us, the outcome of this question, and do well to ensure you solve it. It's very simple. A line drawn from the center of a circle to bisect a chord which is not a diameter is at right angle to the chord.